Hi guys, let's do the fifth exercise of the exercise I give you. Okay, this exercise we know the intensity, we know the voltage, but there is one resistance that we don't know and we want to calculate it. Okay, so how can we calculate it? First of all, in mixed circuits, it's important to simplify. Well, there is a lot of ways to do this exercise, but mixed circuits always try to simplify as much as possible. In this case, what pattern we found? The serial pattern or the parallel pattern? We see that there is no parallel one because here there are two and here there are two, so this is not just one parallel of two resistance. But we found that these two are in serial and serie, and these two are in serie too. So we can convert this circuit into this one. Here the resistance, and here we convert. Wait, sorry. We convert these two into that one. That will be the value of the resistance will be 2.2 kilo ohms, and the bottom one. What's the problem of the bottom one? We don't know this one, so we can't plus it. So we don't know the value of the bottom resistance. So well, we put as we don't know it. And then we know the intensity, we know the voltage, and this one is 4.7. Okay. Now, what pattern we found? The parallel pattern, right? Because serial, there is no one that is in serial, but we find that these two are in parallel. So we can simplify another time. And the same. To simplify this, we must do the 1 divided 1, R1 plus 1 divided R2. But as we don't know this one, we can just put an ask a symbol of question. Uh, Here 4.7, and as you see here, we just have a serial circuit where we know the intensity and the voltage. Okay, so easily we can find what is this resistance. It's a exercise that you must know how to do it perfectly because we did it in the last exam and I was explaining it a lot of times. To know that, just calculate the total resistance doing in voltage total divided intensity total, and okay, and then we have the answer that it's 10 divided 1.6, and I don't know, I think it's 3 something like 6.1, maybe 6 something. I don't care. Let's say 6.11, and then we subtract with the other resistance. So in this way we found that resistance. So resistance 2 will be the resistance total minus the resistance 1, and this gives us 6.1 minus 4.7. This is 1.4, right? Yeah, 1.4. 1.4 kilo ohms. Okay, so we know now this this equivalent of this simplified resistance. So now we know that the answer of that parallel, all that inside circuit will be 1.4. Okay, and there is the ways that I explain this. First of all, we can just use the parallel formula to calculate it easily. or the other way is using the voltage and the intensities. Okay, the most easier I think is the resistance way, because we know that here the resistance total, well, the resistance of all the parallel, okay, will be the 1 divided the branch of the top, okay, that will be 1.2 plus 1, this is 2.2 plus 1 divided the 2 kilo ohms plus the thing that we don't know, okay, that is our uh, variable, no? It's, I don't know how to say in English, but just this, the x. Yeah, 2 plus x. And now solve this equation, because we know that the resistance is 1.4. To solve this, we just do 1 divided 1.4 minus 1 divided 1.2. This will be equal 1 divided 2 plus x, and we use the calculator to calculate this. 1 divided 1.4 minus 1 divided 2.2 is 0.26. So 0.26 is equal 1 divided 2 plus x. Then we have that 1 is equal 0.26 multiplied by 2 plus x. And yeah, and then we just solve this. That is easy. Doing 1 equal 0.52 plus 0.26 x, and finally we got 0 x x equal 0.48 divided by 0.26, and the answer will be 0.48 divided 0.26, yeah, 1.85, and we have 1.85 kilo ohms. But yes, we are supposing that 10 divided 1.6 is 6.1, so it can be a bit different of the result. Okay, but yeah, this is one way to do it. The other way we have is to calculate the intensity and the voltage of different resistance. So finally we found the two things we need here. That here we need the intensity to calculate the resistance of what, I don't know how to call this resistance, the Enigma resistance maybe. The Enigma resistance will be equal to the voltage Enigma divided into intensity Enigma. That is intensity that is passing from this parallel, and the voltage, we don't know it. But yeah. So how can we know the voltage and the intensity? First of all, we have to know the voltage of the big resistance. Okay, this is big resistance. If you want, it is simple to understand if you use the table. Well, maybe, yeah, maybe we can do it too. But it will be a longer video, I think. One moment, boom, this out, and I create the table. Table, boom. It's a big table. Resistance, intensity, and voltage. And how many resistance we have? We have resistance 1, 2, 3, 4, Enigma, and yeah. So, for example, here is one. Well, first of all, total. Total. 1, 2, 3, 4. Oh, I have no space. And Enigma. Okay. Then we create the sub, the two sub resistance. Okay. So this resistance we also have to put into our table. Okay. I don't know how to put it. More space. Let's go. Opa. It is okay for you if I put here like 6, 7, and 8. Okay. So 6, 7, and 8. Yeah, 6, 7. Then yes. Then what we know? We know the total voltage, that is 10 volts. Also we know the intensity 1.6. Also we know the value of these 4 resistance that are 4.7 and 1.2, 1, 1, 4, 2. Yeah, I think that nobody uh, will see this, but okay, if someone see this, is literally a genius. And then the 6 is the plus of these two, as we know, because it's the simplified resistance. It's 2.2. The 7 we don't know it, and the 8 we also don't know it. Then the intensity of these two are the same, okay, in this circuit. So the 8 and the 1 will have the intensity of the total. So 1.6, and the 8 is also 1.6. And the voltage, we don't know it, but we can calculate it. Yeah, and the last time we calculate the resistance, so I don't remember what is, but just divide these two. But we don't need now. To calculate the voltage of one is intensity per resistance. So where is my calculator? Where's my here? And we do 4.7 times 1.6, and it's 7.5. 7.5. So, as you know, in serial circuits, the voltage total is the voltage 1 plus voltage 2. So we know that total voltage is 10. We know that the voltage 1 is 7.5. So voltage 2 will be um, will be 2.5. Okay, if you don't understand this, ask your math teacher because you're a bit cooked. And then 2.5. What is 2.5? The voltage of the 8 resistance. Okay, the voltage of this one. With this, we also can calculate the resistance of this and do the same as the last way. Other things. We know that now. Okay, and when we know the voltage of 8, as we know that we do a parallel transformation to achieve the 8, then we know that all of these will have the that that voltage, 2.5 voltage. So in a parallel circuit, and this parallel part, the upper part and the bottom part will have also the same voltage. So 6 and 7 will have also 2.5 what is this voltage? Volts. 2.5 volts. 5 volts. Okay. Yes. Then what we can calculate now? The intensity, this intensity with Ohm law, no? So 2.5 divided 2.2, and it's 1 point something, like 1.1, 1.1, and yeah, and now we know this intensity and this intensity. We know the intensity that comes into the parallel and the intensity upper the parallel. So for Kirchhoff law, and because this is a okay, I will put you here because you maybe see it better. If we have this one, we have a parallel circuit. So if we know the intensity here and the intensity here, we can calculate this intensity because in parallel, intensity total is intensity 1 plus intensity 2. So intensity total is 1.6. This will be equal 1.1 plus the intensity 2, that is the intensity of the bottom, this intensity. Okay, that is also the intensity of our mysterious resistance. And in this case is 0.5. 0.5. So now, what is this for? No, 4, and our resistance have this 0.5 intensity, 0.5 and 0.5. Okay, and 2 has 1.1. Okay, because 6, this intensity is the same in all the upper branch, and intensity of 7 is the same of all the lower range. Okay, so 7 is 0.5, and for this these two are 0.5, and 6 is 1.1, so 2 is 1.1, and I I missed that because this was not the correct one. This is the 3 is in the upper one, so the upper one has 1.1, and the bottom one, that is our mysterious, has 0.5. Okay, we we have one of the two. We have just to calculate the voltage. How can we can calculate the voltage? Now we have this parallel serial pattern of a resistance of 2 kilo ohms, and our mysterious resistance, but we know that the voltage of all is the same of 7, so 7 is 2.5 volts, and we know the intensity here. Okay, if we know that the intensity here is 0.5. So now we can calculate, for example, the the voltage of resistance 3. Voltage of resistance 3 will be 1 multiplied by 1.1, and this is 1.1. We know that the voltage at the bottom is 2.5 volts, and this one has 1.1, and in parallel circuit we know this, the voltage, the plus of the voltage. In a serial circuit we know that the plus of the voltage has to be the voltage total. So in this case we just subtract this into this, and we have 1.4 volts, and we know now this and this. So 1.4 1.4 volts, no, I said yes, and 0.5 in the intensity. So we multiply, and now it is 0.7. Oh, sorry guys, the 1.4 was the voltage. 1.4 was the voltage. Why do you didn't tell me that? The 1 point. I'm used to not be listening, and when I ask in class, nobody asks me. When I do questions in class, nobody asks me. So it is like staying in class. No, super sadgy. This one, I'm a bit crazy now. Yeah, the resistance. We want to talk about the resistance is voltage divided intensity. Voltage is 1.4, and the intensity is 0.5. So it's like multiplied by 2. So it is 2.8. Okay. Yeah, it is not the same result as the other way, but just because I literally invented some calculations and I don't use the calculator and I do in my head, so more or less. Okay, that are the two ways. If you have some questions, ask me.